All right, I'm going to slowly introduce you to more language. So is this vector B a linear combination of the vectors formed from the columns of A? So what that means, and you're going to get used to this, the column vectors are these A1, A2, and A3. So you can think of this matrix A, and we're going to be doing this a lot. So A1, A2, and A3. So no commas, right? So you see there's no commas between here because I'm talking about the column vector A1, the column vector A2, and the column vector A3. Okay, so what that's saying is, are there x's, right? Is it true, or can I find x1 times the column vector A1? Is there an x2 that I can find times the column vector A2? And then is there an x3 that I can multiply times the column vector A3 to get to the vector B? So this is going to give me that augmented matrix. So let's go right to it. So I'd have 1, -4, 2, 3, 0, 3, 5, -7, -2, 8, -4, and -3. So writing by row and keep neat and organized, and making sure every time you put the matrix notation around it. Okay, so I've got the 1 in this position, right? So my next job is to get a 0 here. So I'm going to multiply row 1 by 2 and add it to row 3. So I'm going to keep row 1 the same. That's a 3. Yeah. Trying to write neat here. That's a 3. This row I'm going to keep the same. And so when I multiply row 1 by 2 and add, I'll get a 0, 0, 0, 3. Okay, so this is an augmented matrix, and this refers back to that theorem that if I have this pivot in the last column, what that last row means is 0 equals 3, because this would be 0 times x1 plus 0 times x2 plus 0 times x3 equal the number 3. So this means it's an inconsistent system. Inconsistent. And so now we need to make sure that we're answering the question. So what's the question? No, the answer is, the question is B a linear combination of the columns of A? So we answer the question. So no, B, we have to put a hat on B, is not a linear combination of the columns of A, so of the matrix A. So A doesn't need a hat, but anytime I write a column vector, I need to put hats on them. And you notice I put hats on top of the A's because they were vectors. So when we're typing them, we can make them bold, right? The A's and the B here are bold, but when we write it, we have to write it with the hat on top of it. All right, let's move to this next one. So is this vector B a linear combination of these two vectors? So make sure you're always thinking context. So really what that is saying, is there a vector, is there a number x1 that I would be able to put in front of A1, a number x2 that I could put in front of the vector A2 that would get me to the vector B? So there's two variables, two numbers that I would be trying to find. Okay, let's put together our augmented matrix. So I'd have 1, -5, 3, 3, -8, -5, -1, 2, and H. All right. So you know my nice pivot here of 1 is good, but I need to get zeros in these two positions. Whoops. Need to get zeros here, and I need to get a 0 here. So to do that, I'm going to multiply -3 times row 1 and add it to row 2, and then I'm going to add row 1 and row 3. So I'm going to keep this first row the same. The second row turns into this, and the third row turns into this. All right. So next I want to get a 1 here. So I'm going to multiply 1/7 times row 2. 1/7 times row 2. 0, 1, -2. And I'm going to keep this last row the same. And then I'm going to take and get multiply row 2 by 3 and add, I'm sorry, row 2 by 3. I did everything backwards there, wrote it backwards. So multiply row 2 by 3, and I'm going to add it to row 3. All right, so this first row stays the same. And then I get 0, 1, negative, that stays the same. And then when I add, I get 0, 0, h minus 3. All right, so again, this is my augmented system. So I need to find out what does h have to be so that this system is consistent. So to make this consistent, this will be consistent if h equal 3, because then I would have 0 in this position, and that would make it consistent.